Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 123 is on the screen. Let's get started, please. All right. Here we go. For the sake of time, here we go. Number 1, 4 to the negative 2 became 1 over 16. Hands if you got that. All right. 1/5 to the negative 2. You distribute. That became 25. Hands if you got that. That is correct. Or 25 over 1. 1C. 2, what was it when it was inside of the radical? It was a 4. Then we had a 3 in there, 4 times 3, so that means that's square root of 12. Number 2, 2 to the x minus 4 is 2 to the x times 2 to the negative 4, which is 2 to the x over 2 to the 4th, which is 2 to the x over 2 times 2 times 2 times 2, which is 16. Number 3, 4 to the 1/2 power, that's square root of 4, which is 2. 49 to the 1/2 is square root of 49, which is 7. Let's go with C. Let me zoom in for that one just to make sure we got it. 27 to the 2/3, we need to rewrite it first. That is 27 to the 1/3 times 2. 1/3 times 2 is the same as 2/3. Well, start with this. If 1/2 is square root, that means 1/3 is cube root of 27. From there, bring down the exponent of 2. What number times itself 3 times to give us 27? That is 3. Bring down the exponent of 2, so 3 to the 2nd is 9. Okay, we good? Yes, Mr. Q. And your graph, you should have been able to graph that by yourself using a table, but I'm going to go to number 5. Number 5, it says, find the sine, cosine, and tangent of angle B. So this time we're focusing on angle B. So you circle your angle B, picture yourself over here, and you're looking at the triangle through that lens. So first thing you should do is label your hypotenuse so that you know that that doesn't change. And then from there you go with the perspective as to what they're asking for. So start with sine of angle B. Sine of angle B is opposite over hypotenuse. So we write sine of angle B opposite over hypotenuse. So if I'm looking at it through this lens, which side is opposite to angle B? Which side? The correct answer is 4. And what is the hypotenuse? 5. Go to the next one. Cosine of angle B is adjacent side over hypotenuse. So if I'm looking at it through here, which side is adjacent or next to angle B? Well, it's the hypotenuse. One of them is on next to angle B, but that can't be because it's already called hypotenuse. So that means the other side that's next to angle B is 3. So it's 3 over 5. Last but not least, tangent of angle B. And it's opposite over adjacent. Opposite over adjacent. So, what side is opposite to angle B? Well, the opposite is 4. Which one is next to angle B? 3. So this is 4 over 3. And if you got that by yourself, all right, we got it, yes? All right. So send that in, please. And then let me send you the agenda. Give me a second. All right, copy that. Warm up 123, Michael Jordan. Done. Exponential functions. Tonight, another 4 transformations. All right. Once again, session code for today is XVM3J. Write that down, please. XVM3J. XVM3J. All right. So, last night, you should have transformed the parent function f of x, base 2 of x, 4 different quadrants. So, show your neighbor what you did really quick. And then get a Cornell note. All right, here we go. Graph and write exponential functions. I can graph and write exponential functions. So, we already experienced that yesterday. See if you remember, or if you can tell your neighbor a definition in your own words of what is an exponential function. Think about it first. What is an exponential function? What is an exponential function? In your own words, what is it? All right, looks like Mario's got it. Very good, Mario. I see you. Rebecca's got it. Very good, Rebecca. See you. All right. All right. We good? Caesar's got it. Yeah. All right. Once again, for the sake of time, yesterday we said that exponential functions are in this form, f of x equals b to the x, or in this transformation form. But what is so specific that the base has to be a number and the exponent has to be a what? A variable. That's what we concluded yesterday. Gave you guys examples, non-examples, and some hashtags. Now, yesterday, look up, we only focused on the function with base 2. Is that correct? Yes, Mr. Q. All right. From there, we revisited our general rule. We know what H, K, B, and A do. But then we applied it to an exponential form like so. And that's what we use to do our transformations. Yesterday, we started with 3 of them. The parent function, then the green one, then the blue one, and then they look something like this. Is that correct? And we see that H, or the number next to the X on the exponent, always tells us to move the function from side to side. And the last number, which is a constant, always moves it either up or down. Yes? Yes, Mr. Q. All right. And today, we're going to continue here. Copy this one, please. Example number 2. Today, we're going to do more transformations, but without a table. Today, it's going to go a little bit faster. Example number 2, it says transform and write a new function, f of x equals 2 to the x. And this is to clarify some of you that might have gotten confused as to what to do last night. But here it goes one more time. Copy this, please. Transform and write a new function, f of x equals 2 to the x. Get a coordinate plane right next to that. Try to be nice and neat, please. All right? So in order to graph this, guys, we need an HA, So on the side, I want you to write HA, f of x equals. Now, for those of us that are a little bit lost, here it goes. So let me write the general rule for this. G of x equals A times B to the x So notice, look up. The f of x turns into g of x, so it's a transformation. Then we have a parentheses. Does this have an a? No, because there's no parentheses. But does it have a b? Yeah, the b is what? 2. Does it have an x? Yes. In our general rule, after that, it has minus h, and then plus k. And we know that the k is our what, everyone? Our HA. So now that we have it like that, tell your neighbor what the HA is for this parent function. What is our HA? Caesar, HA. 0. That is correct because there's nothing here. So plot it at 0. Get our HA, or horizontal asymptote. There it is. Okay, next, we're going to graph this parent function without a table. So from now on, I'm only going to use 2 points. 0, 1, plotted right there, and 1, 2. Once again, from now on, 0, 1, and 1, 2. Now, so that you know where I got those from, so if I substitute x 0 here, what is 2 to the 0? It's 1. If I substitute x 1 here, 2 to the 1 is 2. And then from there, just sketch it going like that. And that's our f of x. So how many points are we going to use to graph our parent function? Only 2. Are we there so far? Okay. So first of all, we graph this using our HA. So now we're going to transform it and then write our new function. So this is what I want you to do. With blue, I want you to move this. Let's move it 6 to the left and 4 down. 6 to the left and 4 down. So move those 2 points 6 steps to the left and 4 down. Do that yourself. All right, so here goes. 1, 2, 3, 4, 5, 6. 4 down. 1, 2, 3, 4. This one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And we're going to label that g of x. So, with that said, now we need to write our new function. So in blue, g of x equals, did we stretch it or compress it? No, so there's no a. So, parentheses. What base is this? This is base 2. X. Now, if we moved it to the left, tell your neighbor what to write right next to the x. What do we write next to the x if we moved it 6 to the left? All right. What do we write, Elijah, next to the x? Plus 6. That is correct because we moved it to the left. And then 4 down, what do we write outside of the parentheses? Tell your neighbor, 4 down. Everyone? Negative 4. So this is our new function. So, since we moved this, we also need an HA. So, tell your neighbor, what is our new HA? What is our new HA, everyone? New HA, Joseph. Negative 4. All right, so plot it, graph it. There you go. That's how you should have done last night's home plate, but given me a function in each quadrant. Let's do another one. Copy this one, example 2Q. Again, rewrite, transform, and write a new function, f of x equals 2 to the x. Get a new coordinate plane. I'll wait for you, and then I'll give you new instructions. All right, first things first, graph this one without a table with its HA. Tell your neighbor what 2 points are you going to use, and what is our HA for that parent function, please. All right, what's our HA, Gabriel? 0 for our parent function. And what 2 points are we using, Rachel? What 2 points am I going to use for the parent function? 0, 1, and 1, 2. That is correct. 0, 1, and 1, 2. Label that f of x. And that's how we graph the parent function without a table. Now, just in case you didn't see it, look up. When it's 1 to the right, 2 steps up, because this is what? Base 2. 1 to the right, 2 steps up, because we are in base 2. Okay? So, with green, I want you to move this. Let's move it 8 to the right and 3 down. 8 to the right and 3 down. And once you do that, write your new function. I'll give you a head start. Go. 8 to the right, 3 down. While you're doing that, I'm going to write my general rule again, just so I can guide myself. All right, show your neighbor, see what they did right there. See if they have something similar to you. All right, so 8 to the right, 3 down. So this one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. This one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. You label that g of x. So, did we stretch it or anything? No, so there's no a. We're still on base 2. So, if we move it 8 to the right, what do I write next to the x? What do I write next to the x? Let's go with Franco, what do I write next to the x if we moved it 8 to the right? What is it? -8. Hands if you got that? That is correct. And then if we move the 3 down, what do we write at on the outside of that, Franco? -3. So with that said, tell your neighbor our new HA. What is our new HA? Our new HA is what, Edwin? Very good. -3. All right, hands if you got that by yourself. From 1 to 5, how comfortable are you with this? Yeah, we got it, right? All right, let me send you the screen so you can send me your graph. Doing Example 2 super q, write it again, transform and write a new function, f of x equals 2 of x. Get a new coordinate plane going, please. And then I want you to graph the parent function really quick with its HA really quick. I'll give you a head start. All right. Check your work, see if it looks something like this. Once again, the parent function, f of x. All right. So just a reminder, our general rule is g of x, a times b to the x minus h plus k. All right. So now that we have our parent function graphed, check this out. Look up. I want you to transform this, sending it somewhere over there. So you decide how many steps. Once you move it, write your new equation and your new HA and graph it. Go. All right, share with your neighbors, see what they got. Hopefully they have something similar to you. If they made a mistake, help them out, please. All right. We good? All right, let's see. Help me out with this one. Enrique, how many steps did you move it and what'd you do? 7 to the left and, hold on, let me write it out. 7 left and 3 up. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. This one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. All right. Does that look like yours? Yeah. So what was your equation for that? G of x equals what, Enrique? Parentheses. 2x. What is it? Plus 7 plus 3. All right. So that means your new HA is 3, which is right here. And if you got something like that, from 1 to 5, I'll compare you with base 2. Base 2, 5, 5, 5. Okay, we got it. All right, which you should already sent that in, yes? Which takes us to this one, example number 4. Write that down, please. F of x equals 10 to the x. 10 to the x. All right. So what do you guys notice? Not the base changed to what? To 10, yes? So if I was to ask you to graph this, before you do, look up, put your thinking cap on. On the previous ones, we said f of x, we only used 2 points, 0, 1, and 1, 2. Now, why 1, 2? 1, 2, because it's base what? 2. 1, 2, because it's base 2. 1, 2, because it's base what? 2. So with that said, tell your neighbor what 2 points are you going to use to graph this one? What 2 points do you use to graph that one? All right. What 2 points, Jesus? 0, 1, and 110. That is correct. 0, 1, and 110. Turn to your neighbor, let them know why did we use 110? Why did we use 110? Because it's what, Enrique? Base 10. That is correct. And of course, we need our HA, f of x, equals 0. All right. This time, I want you to move it. And let's move it somewhere over here. So transform that with those 2 points somewhere over here, and then write your new equation, please. And I'll send you the screen so you can send me your graph. Go. All right. Check with the neighbor, see where they're at. Where did they move their function to? How many steps to where? All right, looks like Ashlyn's already done. Very good, Ashlyn. I see you. All right, in the meantime, this is our parent function f of x. We're going to move it. Let's go with Abby. How many steps, where, and to? 5 left, 8 down. So 5 left, 8 down. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. This one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And your new rule is g of x equals parentheses 10 what? X plus 5 and minus 8. And your new HA is negative 8. There you go. Hands, if you got something like that. Yeah. From 1 to 5, how comfortable are you with base 10 as well? Yeah, we got it, right? All right, our last one for today. Send that in, please, as soon as you're done with your notes. And this is our last one, example 3. Graph g of x equals 1/3 x. And make a little table on the side in green. All right, so today brings us to this last one. This one, if you notice, the base is actually a fraction. Notice, it's no longer a 2 or a 10, it's a fraction, 1/3 of x. So we're going to fill the table using this. So here goes. I'm going to go with 1/3 to the exponent of negative 2. So, do we know how to use this? Yes, let me zoom in for those of you that don't see it. What do we do that? Distribute. We end up with 1 to the negative 2 over 3 to the negative 2. Can we have negative exponents? No, so we send this one to the denominator, this one to the numerator. This is 9 over 1, which is 9. Do it again. 1/3 to the negative 1. Distribute. This is 1 to the negative 1 over 3 to the negative 1, which is 3 to the 1 over 1 to the 1, which is 3. 1/3 to the 0 power. Any number to the 0 power is what, everyone? 1. That is correct. 1/3 to the 1 power is just 1/3. 1/3 to the second power. Distribute, we end up with 1 to the second over 3 to the second. They're both positive, so this is 1/9. 1/3 to the third power. Distributes. This is 1 to the third over 3 to the third, which is 1/27. All right, let me zoom out. So to graph this, check this out. We need an HA. F of x equals, does it have anything at the end? No, so it's 0. Then we graph each of these points. -2, 9, -2, 9, -1, 3, 0, 1, 1, 1/3, 2, 1, 9, and 3, 127, very close to the asymptote. There it is. So here's a question for you guys. Look up to the screen. Look up. We worked with base 2. We started here, and it goes that way. Start here, and it goes that way. Start here, and it goes that way. But now that we have a base, which is a fraction, we start over here, and it goes that way. What would you tell your neighbor is the difference from these kind to these kind? Talk about your neighbor. What is the difference from one to the other? All right, what would you say is the difference, Gabriel? From these to these. That if it's a base, which is a whole number, what happens to the graph? It increases, yes. And if the base is a fraction, what happens? It goes down, it decreases. That is correct. So, to close this, look up please. From our general rule, when our base is a whole number, it increases. And if the base is a fraction number, it what? Decreases. Yes? From 1 to 5, how comfortable are you with this? We got it, right? So tonight you have 4 more transformations. Make sure you get that done. Get the practice in. Those of you that are following on YouTube, make sure you get some practice. See you guys next time. Peace.